Hello students, once again welcome to the LJ Institute of Engineering and Technology. Let's start with the course Mathematics 1. Today's chapter is partial derivatives and today's topic is implicit differentiation. What is implicit differentiation? For that, first we will understand implicit function, then we will see the implicit differentiation. This is so easy based on the only formula. Okay, so let's start with the first implicit differentiation. So any function of the type f of x comma y is equal to c is called implicit function, where this y is a function of x and c is any constant. Then dy by dx, that means implicit differentiation of this function f, is given by minus del f by del x upon del f by del y. And we know that we can write del f by del x by fx and del f by del y by fy. That means you have to remember this formula by dy by dx. That means this x is in denominator, so differentiation with respect to x in numerator, and y is in numerator, so differentiation of f with respect to y in denominator. That means in cross method. Okay, so this is the formula of dy by dx that you have to use in example. So let's look at the example. Example is find dy by dx if this function is given. This is implicit function, which is the mixture of x and y, where y is a function of x. This topic you already studied in 12th standard, but you were using different method there, and here we are using simple direct formula by using partial derivative. Okay, in 12th standard you don't know about the partial derivative, that's why you were using that whole process by differentiating with respect to x and everything, but here we are using only direct formula. For that, first we will take f of xy, that which is given function, and we are differentiating with respect to x partially, so differentiation of this is 0, differentiation of x square is 2x, and differentiation of sine xy is cos xy, and differentiation of xy by chain rule is y, because we are differentiating with respect to x, so y constant and x gives 1. So by simplifying we have this minus 2x, y multiplied to this here, not in bracket, not in angle, so y cos xy. Same way differentiating f with respect to y partially, so treated as x as a constant, so differentiation of y square is 2y, differentiation of x square is 0, differentiation of sine xy is cos xy, and differentiation of this xy with respect to y gives x, so multiply x to the cos here. Okay, now by using only formula dy by dx is equal to minus del f by del x upon del f by del y. So just minus as it is, put the value of del f by del x in numerator, value of del f by del y in denominator, and multiply this minus to the numerator. We have the final answer. So easy, no need any other calculation. Just find differentiation with respect to x and y partially, okay, and just put in this formula, you will get the answer. So easy. Okay, now one more example. By using partial derivative, find dy by dx for the function which is given here at point 0 into 0 comma ln2. That means after getting the value of dy by dx, we have to put the value of x is 0 and value of y is ln2. So first same process, start with the solution. Let f of xy, which is given x e raised to y plus sine of xy plus y minus ln2, differentiating with respect to x, so differentiation of x into e raised to y is e raised to y, because differentiation of x is 1, differentiation of sine x y is cos xy into y, and differentiation of y and L log y will be 0. So we have this answer. Now differentiating partially with respect to y, treated x as a constant, so x constant, and differentiation of e raised to y is e raised to y, differentiation of sin xy is cos xy, and differentiation of xy is x, because we are differentiating with partial with respect to y. Differentiation of y will be 1 and ln 2 will be 0. So we have this. Now by using formula dy by dx, we will put the value of del f by del x in the numerator and del f by del y in the denominator. So we have this answer. Now we will put the value of x and y, that means x is 0 and y is ln 2. We will get this answer. How? Have a look here. If x is 0, so cos 0 is 1, so this is 0 and cos 0 is 1, so we will put y to e raised to ln 2 and plus ln 2, and this minus as it is, divide by x is 0, so this term is 0, this x is 0, so this term is 0, so only 1, so the denominator only 1. Now we know the formula e raised to ln x gives us x, so that means e raised to ln 2 gives 2, so 2 plus ln 2, this is our final answer. Now we have implicit differentiation for 3 variables. That means f of x, comma y, comma z, which is also implicit function, and where z is a function of x and y. So if we put z whichever given, so ultimately this function is function of x and y, is 2 variable, and previous function is function of 1 variable because y is a function of x. Okay, so we can find del z by del x by this formula and del z by del y by this formula. That means, as I told, here z is in numerator, so with respect to z in denominator, and x is in denominator, so with respect to x in numerator. Same as here. To make remind in your mind, I have just given this clue, otherwise you have to remember this two formula. Okay, and one remark, this remark is depend or this is related to this previous lecture, that means for x and y. So if f of xy is equal to 0, then we know that dy by dx is this. We already seen, and we have seen 2 example also. But for the second order derivative, that is d square y by dx square, we have this formula. That this formula is minus outside of the bracket q square r minus 2pqs plus p square t divided by q raised to cube, that means q raised to 3. And what is the value of this pqrst? That you know, that p, that means del f by del x with respect to x partially, q, that means del f by del y with respect to y partially, r, that means del square f by del x square, that means 2 times with respect to x partially, that means differentiation of this again with respect to x, s, that means del square f by del x del y, that means differentiation of this x with respect to y, or you can differentiate this y with respect to x, both are same because we know the mixed derivative theorem, and t, that means del square f by del y square, that means differentiation of this y with respect to again y. Okay, so this is our formula for d square y by dx square. So let's have a look on the 2 different example, one example from this and one example from this. So let's have a look on the example. First example, we have find the value of del z by del x and del z by del y using partial derivatives for the function this at point this. So let's start with the solution. Let f of x, y, z, here you can see x, y and z 3 variable is given. So we have this function. Now we will differentiate this function with respect to x, with respect to y and with respect to z because we have 3 variable. So first we will differentiate with respect to x. So differentiation of x is 1, e raised to y is constant, so as it is. And in this term there is no x, so whole term is constant, and whole term is constant, so it is 0, it will be 0. 2 as it is. Differentiation of ln x is 1 by x, and differentiation of this 2 constant is 0. Now differentiating with respect to y. So we have x constant, differentiation of e raised to y is e raised to y, differentiation of y is 1, and e raised to z as it is, and this 0. Differentiation of f with respect to z partially. So we will treat x and y as a constant. So this term will be 0. So we have derivative of this and y constant e raised to z and differentiation e raised to z. And in these three terms there is no z. So all these three differentiation of all these three terms is 0. Now we will write down the formula of del z by del x, which is minus del f by del x in numerator, this one, because, and del f by del z in denominator. So just we put the value. Same way we will find del z by del y. So formula we know, minus del f by del y upon minus del f, del f by del z, minus only one time. So we will just put the value of these two from this 3 value, and we have this. Now we want to find these two value at point 1 comma ln2 comma ln3. That means value of x is 1, value of y is ln2, value of z is ln3. So put this point in this answer. So we have, first if we put in this, we have del f by del z by del x is equal to minus as it is, e raised to y, we have y is ln2, so e raised to ln2, and as just we have seen previous, answer is 2, and plus 2 by x, x is 1, so 2 by 1 is 2, so 2 plus 2 is 4, which is here, and in denominator y is ln2, so this is ln2, and z is ln3, so e raised to ln3 gives answer 3, so we have 3, and we know the logarithm rule, 3 log 2, we can write log 2 raised to 3, 2 raised to 3 is 8, so we can simplify in this term also. Same way, we will find del z by del y at this point. We will put x, y, and z, and the individual y and z. Same, we have this answer. So this is the implicit differentiation of three variables. Now one more example to find or to understand that the square y by dx square from the implicit function. Okay, so first we will take f of xy, that is x raised to 5 plus y raised to 5 minus this is equal to 0. You have to make is equal to 0 as the given in the instruction. Now we will find the value of p, q, r, s, t. So what is the value of p with respect to x? Differentiation of this is 0, and differentiation of this. Now q, that means partial differentiation with respect to y, keeping x constant. fxx, that means r, that means differentiation of this p with respect to x again. S, that means differentiation of this p with respect to y, and in this there is no y, so differentiation is 0 because it is partial derivative. And t, that means differentiation of this q with respect to y again. So we have all the 5 values. Just write down the formula and put the value of q, that means 5y raised to 4 whole square, r, that means this 2x cube minus 10a cube, plus we have as 0, so this middle term will be 0, no need to write down, plus p square, p multiply p, that means 5x raised to 4 minus 10 a cube x whole square, and t, that means 20y cube upon q cube, that means q, that means 5y raised to 4 cube. Now we don't have a space, so we write this formula, this step again, and we have this formula as from the previous. Now just we simplify this whole square, this one, taking 5 common from this, and taking 5 from common from this, so 5 square, that means 25, and we have this term, and denominator whole cube. 5 raised to 3, that means 125, and y raised to 4 whole cube, that means y raised to 12. Now from numerator we will take common 125 y cube from here and here, and 125, that means 25 5s are, and 25 5 from here. So remaining terms, if we take y cube from here, to y raised to 5 in this bracket, plus 25 we have taken outside, and y cube also common, and 5 from this 20, so we have 4 remaining, and this whole square we expanding this whole square by using a minus b whole square formula. A square minus 2ab plus b square, and denominator as it is. By cancel out 125, y cube is this 12, so we have 9. So in denominator y raised to 9. Now we will put the value of y raised to 5 here. Why just we put value of y here? Because other than this y raised to 5, there is no any y in numerator, and y raised to 5 value coming from the question, x raised to 5 plus y raised to 5 is equal to 5a cube x square. So we just taken y raised to 5 as a subject, so x raised to 5 this minus x raised to 5. By expanding this bracket and by cancel out similar term, so a cube x raised to 5, a cube x raised to 5, a cube x raised to 5, we will get a cube x raised to 5 this term, because we have 16 minus and this 22 plus, so this is plus. Now a raised to 6x square and a raised to 6x square, and this both term will be cancelled out, so we have a raised to 6x square and denominator as it is. From this we can take common 6x square and a cube, and y raised to 9 we have x cube plus a cube. This is our final answer. Okay, so there is no any concept, just you have to simplify step by step, just main focused on the formula of d square y by dx square. Okay, you have to keep remember that formula. Okay, now this is the last example of this topic, that find dy by dx when cos x raised to y is equal to sin y whole raised to x. I have just given this example to just observe what I have just done different. I have just taken logarithm on both sides. Simple, because there is an x and y on the power. Okay, to remove this power, to make the given function simple, we have to take logarithm rule, and we know the one formula of logarithm, log of a raised to x is equal to x log a. Okay, so this y and this x come to the forward, and by taking this term on the left hand side we have f of xy. By differentiating this function with respect to x and y partially one by one, we have these two answers, and we have formula dy by dx is minus fx, that means del f by del x upon del f by del y, and by putting simple value of this 2 and multiply this minus to the numerator, we have the final answer. Okay, and these are the some DIY, that means some practice example that you have to do it yourself, and as we discuss, practice will help you to understand topic very well. So keep practicing, do it yourself. If you find any query, then feel free to contact me. I will give you solution and help you to solve the example. So keep watching. We will see you soon with next topic. Thank you very much. Thank you.